So in this video, we're talking about modeling with right triangles again for a third time, and we're going to start off by talking about granular substances such as sand or salt, or in this case, in example 16, rock salt. Now what's neat about granular substances is that they naturally settle at different angles when stored in cone-shaped piles, and that angle theta is called the angle of repose. So if you see that angle of repose, we're probably talking about some type of granular substance like in example 16. So we're told that when rock salt is stored in a cone-shaped pile 11 feet high, the diameter of the pile's base is about 34 feet. We want to first find the angle of repose for this rock salt and then figure out how tall is a pile of rock salt that has a base diameter of 50 feet. So let's start with part A. We're going to need to draw a picture. When we're talking about any type of word problem like this, modeling with triangles, we probably need to start with drawing the picture. So here's a side view of my cone-shaped pile of rock salt. We know from the problem description that it's 11 feet high, and we know that the base diameter is 34 feet. All right, well, automatically, I'm going to assume that the peak of my pile is exactly in the middle, so it's going to cut my diameter in half. So this piece is going to be 17 feet, and this piece is going to be 17 feet. Okay, again, this is just a sketch, so it doesn't have to be perfect. And what we're asked to find in part A is the angle of repose, or what is that angle that the rock salt is naturally stacked up at. So I'm going to actually just, obviously now I've made a right triangle. And what I'm going to do is label my triangle. Anytime we're have a right triangle, we need to start off by labeling it, and it's always based on where our angle theta lives. So based on theta, 11 is going to be my opposite side, 17 is going to be my adjacent side. And we should know by now that opposite and adjacent, when we have those, we're going to use tangent. I want to find the angle, so I'm going to use my inverse trig, so that's inverse tangent of opposite over adjacent, so 11 over 17, and that should give me my angle of repose. Now, it doesn't tell me do I want my angle in radians or degrees, so I'm going to use degrees because that's what I'm more comfortable with. Alright, so make sure my calculator is in degree mode, and then I'm just going to type it in. So second tangent 11 over 17, and I get my angle of repose is approximately 33 degrees. Now I'm rounding to the nearest whole degree. Obviously, the more decimal places you include, the more accurate it is. So I'm going to call my angle theta 33 degrees. Great. Now in part B, we're told that this pile of rock salt has a base diameter of 50 feet, and we want to know how tall it is. Well, since we're still talking about rock salt, we now know that the angle of repose is 33 degrees. So for any pile of rock salt, that angle is going to be the same. So now we know the base diameter for this pile is 50. We want to know the height of the pile, and we know that the angle from part A is 33 degrees. Well, again, since my base diameter is 50 feet, I can split this up into 2 equal halves. So the radius of my pile is going to be 25. And when I do that, I make a right triangle. Since we have a right triangle, we need to start off by labeling the pieces that we know. Based on my angle, H is going to be the opposite side, and 25 is going to be my adjacent side. So since we're finding the side length, H, we're going to use regular tangent. Again, opposite and adjacent is tangent. So I'm going to say tangent of 33 degrees is equal to opposite over adjacent, so H over 25. And now I need to get H by itself, so I'm going to get rid of this fraction by multiplying by 25 on both sides. So 25 times the tangent of 33 degrees, and that's going to be equal to my height. So let's type that in our calculator and see what it comes out to be. So 25 times the tangent of 33 degrees. Again, I'm still in degree mode from the previous problem. I get about 16.24 feet. I'm rounding to 2 decimal places. So in part B, when the base diameter of my pile is 50 feet, that means the pile of rock salt is about 16.25 feet tall. That's it for this example. Let's move on to another one. In example 17, we're told that we have a crane that has a 200-foot arm whose lower end is 5 feet above the ground, and the arm has to reach the top of the building that's 130 feet high. What angle theta should the arm be set? So again, we're going to model, so we're going to start off by drawing a picture. I'm going to start off by drawing the ground. My crane is sitting on the ground, and it's just a sketch. So here's my crane. He's got some tires. All right, and yeah, that's a pretty crappy drawing, but again, I'm not an artist. And we're told that the crane's arm is 5 feet off the ground. So here's the crane's arm, it's 5 feet off the ground. And it needs to reach the top of the building. So it's got some windows and stuff in it. So the top of the building, that's 130 feet tall. All right, well, we want to know what's the angle that the crane arm should be set at. And again, don't forget that the crane arm itself is actually 200 feet long. Okay, so what we need to do is first use the information that we have. If the building itself is 130 feet tall and the crane arm is set 5 feet above the ground, then this distance right here is only 125. Okay. Now what we've made is a right triangle. We've made a right triangle right here, and since we have a right triangle, we need to start off by labeling the parts. Well, and it's always based on where the hypotenuse is. So 125 is going to be the opposite side. 200 is going to be the hypotenuse because it's directly across from the 90-degree marker. All right, so now we need to think about, all right, which trig ratio, sine, cosine, tangent, uses hypotenuse and offset. By now, you should realize that's sine. But since we're finding an angle, we're going to use inverse sine. So sine inverse of opposite over hypotenuse, because that's the rule for sine. So 125 over 200 equals. Now, it doesn't tell us, does our angle need to be in degrees or radians? So I'm going to go in degrees. You can do radians if you want to. Just remember your answer is going to be slightly different than mine. I'm doing degrees. Make sure your calculator is still in degree mode. I am. So I have sine inverse of 125 divided by 200. And I get 38.68. I'm going to go ahead and round that to about 39 degrees. So I just rounded to the nearest whole degree. That's okay. It's not great, but it's all right. Obviously, the more decimal places you include, the better. So now we found that the crane arm should be set approximately 39 degrees to be able to reach the top of this 130-foot tall building. Okay, and that's it for this example and this video. Let me know if you got questions.